Hello, everyone. All right, so we're back from our break. So tonight we have Eric Manganero, CTO of Zap Protocol. He's going to talk to us a little today about Haskell programming and get up into some other topics as well, regarding some of the things we have going on at Zap. So without further ado, please welcome Eric.
Hello. So I learned my lesson the last time I was here. I was like, oh man, I'm so nervous. I'm going to wear a suit and everything's going to be, and it was like just as hot, if not hotter, when I got here. And I was like, man, this is the worst idea. So now I'm just in a t-shirt, so it's all good this time. I also, I'm really, everyone give it up for Hassan. That was a really good talk. And really fortunate because I literally gloss over those types of topics. I just assume you know everything that I know. I'm just gonna steamroll over everything. I'm like, all these little concepts that I forget, even as foundational as explaining what a smart contract is, like you did a really good job of that. And I'll just be like, yeah, you understand what a smart contract is. I'll just completely blow over it. And that's something that I have to be conscious of right now, especially as we move in. And I want you to stop me if I'm moving too quickly, or if you really don't know what I'm talking about, because I will literally just keep on going. I'm also extremely, kind of ADD about the way I talk about stuff. So the way I thought today's procedure would be like, okay, I'm gonna go on the mic and talk about Haskell as if I'm a Haskell developer. Definitely not. But something that really resonated with me, what you're saying, is that I do run a production team who are predominantly object-oriented programmers, not necessarily functional programmers, which are a lot of stuff that we're going to talk about today. So I'm not speaking from I don't want to put off I'm speaking from a point of authority, but speaking of somebody who is a part of that, I guess we're studying it together, So if this was a YouTube video, this is me reacting to Haskell, basically, because Haskell is kind of it's kind of daunting. There's a lot of stuff that I don't know about it. The only other person that I've actually ever spoke to about Haskell is actually Dan, who's in the audience here. So he's really cool. But we I think that's the only other person I've actually had a serious conversation about it, and that's about it. And now it's a topic of discussion for a talk that I'm giving to all of you now, and now you're going to listen to me as if I know what I'm talking about. But I'm going to play clips from stuff that I thought was extremely thought-provoking, and it looks like these guys already made me slides that I don't have to redo. So first one, we're talking about Clojure is another prominent smart contracting language. I think this guy's name is Richard. He works for another functional programming language called Elm. And let's just let him talk for a second, and then we'll briefly just let him talk and figure out. I thought his main thesis of the statement, and let me just reel it back in. My thesis for the entire talk tonight is, to use one of his words, Haskell could be the killer app that makes it popular. Or if I were to say it once, smart contracts might be the killer app for Haskell. Why is that important? We're gonna go on a little journey. I'm gonna try to make this as fast as possible, but Sam is gonna talk about real quick.
In this list is 0 out of 10. But that's
he's remarking right now about developer population. And he talks about three main things about what makes any programming language important for literally all of it. And he's like, okay, why isn't there more functional programming languages? Like Hassan said earlier, the Haskell is a functional programming language. Why do you care? Right here is a graphic that he put out. There's JavaScript, Python, Java, C#, blah, blah. And he makes a joke right here.
10 languages, in terms of usage, thusly. And this is probably no serious surprises here. JavaScript, Python, Java, and so on and so forth. These are probably languages we've all heard of. It's also not a huge surprise that unfortunately the total number of functional programming languages in this list is 0 out of 10.
Yeah, there we go. Funny joke. Now, that is, he's going to tell you why, I guess, why. Yep, question.
What's the functional, like, what is that?
Okay, so what is, so let's go back over for what functional is versus, I guess, what you would call like object-oriented programming. I think that's super important because if we're talking about Python here, and I actually have some basically like an object would be like, okay, let me try to make this really simple. If we're talking about a database, maybe you'll have like a spreadsheet, like a Excel spreadsheet, and then you know like a bunch of people in here, and it's like a person, their first, last name, and their address and their phone number, right? That's an object. And that's kind of like what the paradigm is for a lot of people to answer your question, is that then we try to use those objects to actually express stuff. So like, okay, you go to the store, I buy something, that's like a receipt, and it has all these things that every receipt has. It makes sense for us to write in objects because it helps us communicate to other developers who are making computer programs. And that's, so business has a lot of that. So you get a receipt, I would go to the store, I buy something with my credit card, and you know, it has your name, it has the cash register's name, you know, what time it was, how much the bill was, all the whole thing. And you can just represent that as an object. And the only difference is I can, like, from my research, when we talk about something that's functional, is something, to answer your question, is directly related to like the blockchain. So like the big word here that everyone uses in blockchain is immutable. Things that can't be changed. And that's something of the major features of functional programming, is that we're no longer going to be like, let's see. I had like some other code up on here that was pretty good explanation of this. But just does that make sense without going too far into it, and then I can keep going? Does that any other questions? Yeah.
Why is the music on?
Say again?
Why is the music on?
Oh, it's because I don't like hearing my own thoughts. And I'm really awkward, so if there's a moment of silence, I'm like, I can lower it a little bit. All right, cool.
Aw, I liked it.
I know, me too.
That was a good choice. I was like, why don't they do that more?
I know, it's because, like, you know, all right, we'll do it half on, half off. We still got some over here. But, so let's, maybe this guy can actually help us understand why these types of languages like Haskell is not on the top.
10. But you know, that's the way things are.
Blah, 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 blah. How do they get popular? Sweet, there it is. You see, he made all these slides for me. I didn't have to do anything. So, how did they get popular? Killer app, cool. He talks about the Apple II. There's something called VisiCalc. It was really cool. Everybody really liked it. And it was the first thing that, it was the first piece of software that people liked so much they went out and bought the computer. So instead of a $100 piece of software, he bought it for 10 grand. It's the killer app. You know, in the beginnings, that was like, wow, I can't believe that we ran business without this. This is so tight, cool. So we talk about the Apple II, blah, blah. VisiCalc was so cool, right? Responsible for sales, great. So, so we have something called Ruby. It's another object-oriented programming language where a lot of people adopted it early on because if you didn't necessarily come from a coding background, object-oriented programming was like very, you know, it's objects. You can see it, you can think about it, and you can implement it really quickly. And there's a program called Rails, and that came out, and it was like, oh wow, I can really put out an app. I can make an app with a couple of my friends. I don't have to spend millions of dollars, and I can put something together, and that's why it's a killer app. It made Ruby really popular for a while. It's not the most popular, but for one reason, we're talking about the why. Like, so we're going to go back, and we're going to loop it back to Haskell in a second. Okay, so it's kind of lame now. I don't like Ruby, so you can see over time that certain websites won't, you know, people invested inside of it, so they're going to keep it around. Cool. Anybody else here of Ruby? Ruby, cool. Well, today you heard about Ruby. It's great. Let's see, PHP. Something that gives me a heartache when I look at it, because I've spent so much time in the gig economy making websites for people who are ungrateful and hard to work with. So, you know, the killer app for dynamic HTML, you know, so you have to be a perfect graphic artist and a perfect, you know, senior engineer, and you have to deploy it all for like $2,000 for somebody. That what was responsible for that for the beginning portions of the internet was WordPress, Drupal. These are things that, like, you probably, if you started your own business, probably use one of those two, because it's super easy. There's lots of plugins that are out there, but the overall insides of it are like, I don't want to use PHP ever again if I don't have to, basically. Cool. He talks more about it. He's funnier than me, blah, blah. Then he talks about C programming. We've heard about C because pretty much any video game you've ever played, if you play like any type of 3D game, it's really fast. You know, it's a really important for that really low level, super fast thing. So you can't, it's meant for like pretty much everything. So C programming is cool. He talks about systems programming, especially because a lot of languages like Haskell are written in C. So there's like a lot of like, it's like really close to the ground. So really cool. It came out because assembly language or Pascal was around, and then nobody wanted to write strictly in assembly language, which is extremely hard, so C won. Okay, so then he starts talking about other programming languages that we're not going to cover. He's really about them. He obviously works at Elm, Clojure, and these are other functional programming languages that are making their way on the scene, but are not quite there yet. And they're saying potential functional programming killer apps. And this is like kind of like why it steered my thought process into what my conversation with y'all today is, that the potential functional programming killer app is Cardano for Haskell. This programming language that has been around since the 70s, and we're going to talk about this guy, Simon Peyton-Jones. He's one of the guys who works at Microsoft now. He worked on it, and he brought up a really good point about, he talked about like language immortality. There's a lot of funny quips that he puts in here. Let me try to find one if I remember clearly. This is the guy that was a part of it. He's a geek. Tight. All right, so yeah, it started in the late 70s. Something that is a part of my gripes with Solidity. We're just talking about the age of a programming language. Solidity sucks. It's only like 5 years old, and it's completely dirt. Why? Okay. At one point, I was like, man, I want to write, like, I was doing some sort of conversion in my program, and I was like, the only time in my whole life I ever needed a trig function, a trigger, you know, I was like, oh, sweet, I need arc cotangent, you know, I was like, whatever, you know, something really, I've never used in a sentence before, but I needed to use it for a calculation. In every other language or any other calculator, I would pick it up and I would try to find it or read the manual on how to do it. Solidity is so young, it doesn't even have those functions in it. It doesn't have the ability, you know, it's not very precise in terms of its like integers. There's a lot of problems to do with buffer underruns and overflows. We can get into those, but there's a lot of problems that come with object-oriented programming, like the ability to be very flexible and having lots of alternatives, which is really great for if you're just like learning and you want to have your mind free, like I could do anything, that's great. And like what Hassan's saying, we're saying we have smart contracts that have millions of dollars running through these things. We can't have every possibility happen. What is it? Yeah, okay. So after your program gets written, there's like all these things that could happen and that might. And as your program gets bigger, multiple people are working on it. People have different levels of experience. The amount of possibilities that can happen, and that red dot is you losing millions of dollars. This result is incorrect. And then that green result is like, oh, the one I wished happened, you know? So as we're moving through object-oriented programming, you can see that without getting into the really nitty-gritty of it, you just produce a lot of possibilities of what could happen inside your code. And Dan said it earlier, I work with that protocol. So we have we have over 25 engineers working on different projects at different times. So that can get this possibility stream of what will happen with my smart contract is so big that at the end of it, I have to literally hire someone to audit my code that is not someone who works there and has clout. One of the only ways for a cryptocurrency to really get more valuable is to have it on more exchanges, more liquidity, and more partnerships. But the thing is that when you're really analyzing it, people are releasing code that has, only a few people in the world that really understand how to take it apart and then audit it, say this is actually what they do. And what the graphic says, formal verification is this process. Now you can do this with Solidity. It just takes it's out of the skill set of a normal developer because they're not going to have that same thought process. For a normal programmer, it's like that one path that I'm thinking about all the way at the edge is the only thing I care about, and everything else, oh, it's not my problem, That's really what happens in a bigger team. It's like if you do one of those routes, you go home at 6 o'clock, you're good. It's actually beyond just like what the capability is of just like a normal person. And we'll get into we did mention lambda calculus. We did mention a lot of, and then his talk was escape from the ivory tower, the Haskell journey. That's what I'm saying is that it's been around since the 70s. It has all the things that I want or need as a programmer, but it's so difficult. And it's not the way that I was brought up on how to think about programming that it's still there. And that's like a big reason to go back to the other talk, why isn't functional programming more accepted, is because it literally is just harder. And we're gonna go into code examples in a second. But when I'm learning a new programming language, I was like, okay, then you're kind of just like looking for syntax. What's interesting, or I guess depending on where you come from, this guy is like, don't fear the monad. There's a little conceptual thing created in computer science called the monad that is related to the entirety of functional programming, meaning we're not going to, just like in the blockchain, change any data. Each thing inside of the blockchain will be immutable, but then how do you do things if you can't save variables or you can't change the state? You have to, I don't think we're gonna get time for this, but the idea is before you can start really programming in Haskell, we have to understand some light category theory, which is a sentence I've never even said before. I did go for my undergrad for math, but I didn't go for my master's in math. I didn't touch on these high-level computer science concepts until now, but they're just as old as the beginning of Haskell and where these things come from. And as we look at the code, we're going to see the differences between something like Python, which is very human readable, goes from A to B, and then we're going to break our thinking up into what the functional programmer does. And I have a very interesting way of doing that, and it is, I was going to code it out. We could probably do it still too, but it's already done, so it's like cooking show style. Ooh, I could code this live, but I did it already. Cool. So every time I learn a new programming language, I do something called 99 bottles of beer. It's an old school method, but so how do we sing it? What's the verse? Okay.
Take one down, pass it around. 98 bottles.
Cool. So in essence, we have an algorithm going on, and at some point in time, we have to have 99 bottles somewhere. we have to take one down and then pass it around. What does that mean in context? I've actually wrote a smart contract in Solidity that had 99 NFTs, and that as soon as you passed it to 3 people, it burned itself and disappeared. So then you would have 98 bottles of beer on the wall. You know, so there's smart contracts that have no real use case other than to learn the actual thing that's going on. So 99 bottles of beer on the wall is, you think, simple. So now we have Python here, which is, let's just look at a creative version of it. And then we can look at a functional version as well. So we we try to break it down. Oh, and that's too much. Let's go for simple. Okay, great. So we're gonna set this big for loop. It has 99 elements into it, and it's gonna go all the way down to 1. And it's like, if it's greater than 1, then it's blank, the number of bottles of beer on the wall, bottles of beer on the wall. Very straightforward. And if it's greater than 2, then the suffix changes. And if it doesn't, then you just tell them that it's only 1 bottle of beer on the wall. And then at the end of it, closes the song and says, take one down, pass it around, and then the suffix. And then you're done. Does that make sense to everybody? In essence, we know how to sing the song. Whether or not you program in Python, it's very straightforward. We can actually, without knowing how to do the syntax, we can read it objectively. I can look through this and I can see what it does, and I can talk about it. Let's do the same thing with Haskell, and I thought that was a very interesting way of doing it, and it's completely different from the way I learned it. When I was, so in this case, we're talking about the state or everything that is a beer. So like in Haskell, you have the ability to create your new different and new data types. So in this case, we created new data types called beer. And we talked this code bit, and we broke the sentences that you could say, but that could never change. So like we said, things are immutable. Once we put them inside this variable, they can't be used again. They can't be changed. So how do we actually move this around? So we actually have something called a monad, which we could go into earlier, but really it's just telling us to show different portions of the song depending on what the value of beer is, what that B is. And what, at the end of the day, meaning this is not the state transformer of this monad, just don't mind the jargon. We'll just do that song in a form of a verse. And then we created this new data type, and it's called a verse, and we're doing all this math inside of it to just run this one line of code. And it will take in 99 bottles of beer, and then it'll sing the verse and then transform it with this. You don't have to know Haskell to understand that it works. We can actually come back over to here. I thought I had it. I lost it. Oh yeah, 99 miles of beer and all. Nice. This is a really cool website. I really like it if you're really trying to have code just usable. It's called Replit. You can do Python, Haskell, a whole bunch of things, and you don't have to waste a lot of time trying to get to the initial, setting your computer up, and you can start running these things. So, here's that big scary word again, monad, and basically some cool syntax highlighting going on here. But at the end of the day, it's just going to sing us the song. 99 bottles of beer on the wall. That's cool. This is not even talking about Plutus yet. I'm just trying, this is me reacting to and understanding the different paradigm of thinking when interacting with something as important and mission critical as money. We want to be able to have a programming language that is older, that's from the 70s, so it has all this time to have a lot of a lot of opinionated and a lot of revision. So we're talking about 5 years, and we're talking, if we go back and use the other vocabulary from the gentleman over here, yes, platform exclusivity. It's very specific. Solidity is written for Ethereum. It's the biggest language for Ethereum. Why? Same reason why JavaScript is so huge. It's like it's the one thing that worked, and then all the developers piled up on top of it, me included. I'm like, I want a job.
I just want to butt in. So Haskell from the 90s.
It's from the 70s. I literally have the whole video.
I just looked at the page. It said
This guy's so old. He'll tell you.
31 years ago.
All right, let's go. Wait, I got proof. All right, here we go. This guy is going back to his undergrad.
We were both studying
70s.
He ended up.
All right, I'm smart, and he's British, and his accent's kind of intolerable. I'm sorry. It's really hard to. It sounds very French, and I was very taken with it. It's like Cambridge. But yeah, there you go. Late 70s, early 80s. But when we're talking about
Where's the music?
where is the music? See, I don't want to be caught in the cold here, you know, because then you have to like listen to me think like aggressively. I'm like, what am I gonna say? Platform exclusivity. Reason why things are popular. The only reason why it's popular is because Joe Lubin spent billions of dollars promoting it, and therefore getting a lot of people anxious to get into the scene. Even me, I'm like, oh man, I want to learn smart contract. Maybe I'll get a job. It'd be really cool. Where would I start that? Ethereum. And not because Ethereum is easy. It sucks, and everyone just has to deal with it because it has the most people. You know, it's just like JavaScript. If I have a problem with JavaScript, I can just ask because there's so many people. It's like ridiculous. And there's like a graph Simon put on here. He's like, okay, there's like a point in time where things just get adopted so much that they become immortal even though they suck. Java. There's so much running on Java, and there's so many people who don't like using Java that it doesn't matter what the people feel or think because there's so many backends. He talks about crystallization, tight. Let me just find the cool. All right, cool. Most programming languages that were like of research nature, like from the, he's like, yeah, one person used it and it lived for a year. Great. And he's going to talk about, oh, successful, 100 people invented it, and then 6 years that it died. Tight. Yeah, here's the other one. C++, Java, Perl, Ruby. The threshold of the immortality that he talks about. Because at some point, C++, Java just got so popular that it just skyrocketed, and now it doesn't matter if it's a good programming language or not. Which I do like C++, but Java's trash, Ruby's horrible. Committee languages, but here's Haskell, and there's so many.
Where it starts though?
Yeah, I know what you mean. Okay, prove me wrong in the middle of my talk. I'm good. No, he knows Haskell way more than me, so obviously he would know. But yeah, so they're talking about Haskell's still kind of dragging along. It's super difficult. You have to have like some sort of like mathematics background to really like fully absorb it. There's people who are programming it for 10 years. They say, I still don't know what a monad is. So it's not like I can even approach it like during this talk. But just like on its pure difficulty, and he's like, yeah, why did that happen? I'm not going to go into it. He's like, he's not sure. This guy has more of a clue. And let's see. See, I actually pulled this video up because he has better slides than me. Because I don't have any. Let's see. Go. I stressed out my entire team this year to learn Go in 3 months. They had no idea. It's popularized by Google. No one knew. Okay, cool. I was like, okay, now this is going to be a really hard month for you. Why isn't the style the norm? It's difficult, and it's based in academia, which this guy talks about. So let's just fast forward into the future. Plutus Playground. Okay, so just to summarize, we'll go into the code, we'll compile it, we'll run it, we'll look at it. Super important to know is that I think that me as a manager looking at the software development process, whatever, we make the best app in the world, and then we have to send it away to an auditor. Certic, I think like for them to look at your smart contracts is like $500,000, $250,000 if it's like a smaller project. That's like insane money. Like they're gonna look at it for like 30 seconds, they already did it, but there are people who are, I guess like objectively, the only people who know how, they know more than me on why Solidity sucks and what they can do to like speak directly to assembly language or the lower level Lisp language, which I don't have fluency in. That should not be the case. And if I want to speed up my development time, it actually makes sense for me to, one, go outside of the Ethereum ecosystem, so the exclusivity is gone. Two, it's faster because not the gas prices are cheaper. We talked about gas prices earlier, how gas prices for DeFi is extremely attractive for Cardano. And it's not Solidity. I'd rather learn category theory than work in Solidity for the rest of my life. I don't know what it is. Like, I'm not from academia, but I'm like, wow, this is, at least I can go to bed at night. Because I have this thing overhanging in my head, and it really sucks when I don't know something. I geek out on something, I will jump down the well and fall down that well for days until I know something, and I'm still falling, and that sucks. And I'm like, okay, so that means literally everybody who's behind me, who's working, doesn't know what's going on. They won't take that plunge. But our success is like pivoting off of exclusive language that is poor and old. On like, horrible documentation. And even if we all simultaneously say there's so many problems with Solidity, it's not gonna change them. So now we have a really old school language that's new, in a new way. So I've spoke very, very quickly on, you can create new types. So you can see right here inside of the smart contracts, we're creating new types. And you can see a lot of here is ledger, playground. This is very important because we are making a blockchain app. They want to be very specific. And we're going to actually say hello world. This is like the beginning program that all the beginners learn. So I'm just going to import this data object I'm going to actually import the entire playground. I'm not going to use the contract. I'm just going to instantiate it here, but tell it that it's going to be a whole blockchain. It's going to be some text that lives in it, and then I'll literally assign it here forever. We spoke about endpoints earlier, contract places that actually will be payable objects. And then here with these arcane symbols, just being able to evaluate the entire schema that was defined here. So if we literally compiled, which is nice about Plutus, you don't have to do a lot of installing. You can compile it right in your browser and simulate it with like a mock chain. Being able to literally say oh, I would like to wait for it. Let's evaluate it. It's going to say hello world, and we're going to be like, pay me, hire me. I'm a Haskell developer. Put this on my resume, and great. So you can just see here in this fake blockchain that one person asked the other wallet, and then for the word hello world. So it's a very simple thing, but in essence, it's extremely complicated in the way that it was handled. But if you fully understood it, and I fully went through this process of on paper describing everything that I ever wanted to come out and making sure that my application only does what I think it does and not these millions of other things, it makes sense for me as a manager to myself learn and have other people learn this arcane or method, and maybe go back into my undergraduate studies and try to unearth some category theory to go to bed at night. I'll go back to go forward. And I'll spend a month learning something brand new, but then I'll replace something that has been a pain in my side for 4 years. And so my end of my talk is smart contracts might be Haskell's killer app. Thank you.
All right. Well, yeah. Thank you, everyone. Thank you, Eric, for the
Oh wait.
demo for us.
Oh, we didn't demo anything.
Oh.
Oh, I forgot. Okay, so I do work for Zap Protocol. We do have a very important so we have a distributed application called an Oracle system that we just deployed to Binance Smart Chain because Ethereum is too expensive. This is a very similar thing that you understand what this is. These are cards with the prices of large cryptocurrencies. But in the back end, we have decentralized miners, just like Bitcoin or Ethereum, where if you ran on your computer and you added some capital, that you would make the Zap protocol network grow. That means that we have people on their computers stake Zap and query like CoinGecko, Binance. So if I asked everybody in this room what time it was, and you guys all told me, like everybody, what time is it?
10.
No, what exactly is it?
9:59.
9:59?
Point 9:59 and 7 seconds.
Sweet. So now we're getting a more trusted answer from everybody in the room. So then I take the medium of that and make sure that it's an odd number amount of people, and then I can actually trust this piece of information. That's what Zap Protocol is doing right now. And that, I mean, a lot of people really just like the idea that you can stake it. That's great too, but you stake it so you can run this software, so you can, there's a big uptick of like desire for like synthetic assets after the Robinhood fiasco, where they're being fined $70 million from FINRA because, people want to buy Doge and they just so happen while that is running, they just shut the servers down. Like, oh, okay. So people want to be able to have, people.
Robinhood, please. Never use Robinhood.
Well, so there's,
Sorry,
it's fine. It's basically like there are financial markets that, people want to have unstoppable. There should not be any reason why that if we're like abiding by the law and that these things are legal to purchase them in the free market, then we have to have an application like DeFi to keep these pieces of information going in any climate. Any type of government being able to shut it down. It's just not something that you want. So for those things to happen, you have to have accurate price information. So that's where our decentralized app comes from. We're on Binance Smart Chain right now. We want to go to Cardano. Like just by that, there's like, people are bringing that type of application and maybe some games to it as well is exactly what the system needs. Like, that's what we're trying to do, and that we're trying to not be married to Ethereum. And we're still kind of married to Ethereum through Binance Smart Chain because it's still Solidity, which will end up writing our contracts. And I think that it wouldn't be that big of a deal, except for now I have to learn some, brush up on my category theory or something. I don't know, but we want to be able to deploy there, and bring partnerships and just develop on it. So Cardano is super attractive to us because it's cheap, you don't have to spend, if people are doing DeFi transactions, people are spending hundreds, if not thousands of dollars in moving larger amounts of money. The capital inefficiency is off of this world. And just being able to write an application is almost impossible in Ethereum because I can't write without having some egregious fee. It's just you can't use it. Why would anybody do that? And a lot of people are using it just as a financial vehicle, and because they'll have maybe hundreds of thousands of dollars on a Uniswap trade, that $300 is nothing. Like, okay, I'll do it anyway. They're still going to do it. They're going to ape in. They're going to jump on top of it. But people who are just beginning, their financial journey, $200 is what they're working with. It's not just the fee. That's like huge, so we want to be able to not, at the same time, create an exclusive place for people with large amount of money to just move money around. We want to be able to have everybody be a part of it. So, yeah, I work for Zap and we're writing applications. That's the end of my talk. It's my TED Talk. I don't want to answer any questions.
Okay.
No, I can't answer questions. Questions?
Are you limiting the assets and you're supporting only tokens, or you do like NFTs and houses?
The question is, are you going to accept more than one asset? Is it just NFTs or tokens? Yeah, I think that we're focused on tokens within the Ethereum ecosystem, but that's just because of the limitations. I'm really open to a lot of different types of assets. We have an NFT marketplace coming out later this month. There's lots of really interesting stuff that you can do with NFTs, not just with art, but if you were talking about collateralizing loans, we're talking about collateralizing pretty much everything. It's like things that are here and they can't be fungible can be refungible again. And we'll talk a bit more about that in another talk. Any other questions? Questions?
This is a silly question.
We'll do one and then we'll do you. Yeah, Leo?
This is probably a silly question. I'm not a programmer, but I know how to code.
Sure.
I agree with you that Solidity is terrible.
Uh-huh.
But why they didn't choose Python? I think Python is amazing. I mean, why you cannot? I mean, the Vitalik choose Python. Everybody uses it.
Very good question.
It's read and write. I mean, you are reading and write a database. I mean.
That's a really good question.
I mean, how complex could that be?
Oh, well, it isn't. And actually, there's a programming language called Viper for Ethereum that was brought out at the same time. But like I said, the developer huddle, the dog pile that happened, the pile for Viper, the Ethereum test smart contract language written for Python, the developer huddle was not as big. It's a very simple question. They died off. Quick note, Viper is a programming language for Ethereum written in Python. But because it wasn't widely accepted, just like I said, there wasn't like the amount of people interested in doing it, then it died. Very simple question, very simple answer.
Okay.
Your answer.
With the solidarity on your like green dot, red dot chart, saying that there's all these different paths, is that one of the reasons why the transactions take so long?
No, that isn't why.
Which case would have succeeded. Then again,
the reason why the transactions take so long is very simple, and I try to make the dictator versus the democracy route. A dictator can just implement a new law really quickly, and consensus is expensive and time consuming. So that's, if you could have one, I could either tell like an entire country what to do it now, or we can come to consensus, and that takes a very long time. People try to cram in voting in one day, in a couple of days for an entire country. Like, it's insane. It's almost not tractable, but we have methods that will help us, because now we have digital machines to help us. But yeah, just the short answer is that consensus is slow, just even if we were talking about non-computers. Does that make sense?
Sure.
Okay. Any other questions?
Yeah. Can you just tell us a bit about Zap Labs and missions and stuff like that?
Other questions? I will, yeah. I love messing with Dan. He's the best. But any other real questions? Because I'll answer questions one-on-one if you don't want to talk out loud, but if any, then we can close up and then we can just have a couple more beers and just talk about stuff.
What is it?
Questions?
No, Eric.
All right, good, thank you.